Hi and welcome to All Things Marvelous. I'm John Paul and today we're going to be building this quick simulation setup to create a liquid vegetation animation like this. This uses a bit of an overlooked force in Blender in my opinion, and I couldn't quite find any tutorials about it. There were a few that mention it, but nothing that had an actual tutorial showing what you can do. That may be because no one cares, but I'd been seeing these really great animations that were made in Cinema 4D and I wanted to try and see if I could make the same results in Blender. With the intro out of the way, let's get into it. So, to begin with, we're going to delete the default cube and add a quad sphere. You can just use a normal sphere here as well. Scale it down and move it up to the top. You can use the camera and the light in the viewport to give you an idea of the scale that I'm working to. Next, create two large spheres and position them as shown, with a slight offset from the main flow object at the top. Next, turn on the fluid settings on the two big spheres, and then set them to Effectors and Collision. Click on the small sphere and go to Quick Effects and select Quick Liquids. Next, play around with the size of the liquid domain to make sure there's enough space in between all of the objects for the water flow. From here, I set the resolution to 64 and start testing out the fluid simulation. Every time I make an adjustment to either the size of the domain, effectors, or the inflow object, I always make sure I press Ctrl A and apply the scale. This will reset the simulation in the event that it doesn't play properly. In the flow settings, I set the flow type to liquid and flow behavior to inflow. What I'm trying to do here is move the collection objects so it's a nice cascading effect between the two objects. Next, I go to the domain and turn on viscosity, and I use the diffusion preset of oil. As you can see, we are starting to get the right type of look now. Next, go to the domain and move the bottom down so that it doesn't fill as quickly, then go over and turn on mesh. At first this is far too thick, so I go back to the viscosity settings and move it down to 0.0001. I'm going to pause the tutorial here to mention that currently in Blender 4.03 there is an issue with the viscosity setting and collision objects. As you can see, it just explodes for no reason. For the tutorial I leave it turned on, but just up the time steps to 2 minimum and 8 maximum. This helped, but it didn't totally fix it. For my final render, I turned it off and turned up the surface tension on the diffusion settings instead to get a more stable simulation. But this is more about the next section where we use the fluid force to control the particles. So with that said, here's the rest of the tutorial. Next up, we need to add another sphere, the same size as the inflow object. And then we need to add a fluid flow force from the force field dropdown. I set the domain object to be the fluid simulation and turned up the strength to 5. Select the sphere and rename this particles. Add a particle system to it and come into the settings. Turn on rotation and under physics, select fluid in the dropdown. Then in the advanced, turn the interaction radius really small, and same with the rest density. Then turn up the stiff viscosity to about half, 0.626-ish. Go back into the two large sphere settings and turn on collision in the physics tab. I slowly over time increase the strength of the fluid force to get the particles moving with the flow of the liquid correctly. Next, go back into the particle settings and increase the lifetime to the frame count of the project, and then the end frame to the same. Also, bump up the number of particles to 2000. Okay, next we need to replace the particles with bits of grass. I'm using Bagapie models, but there are loads of free ones out there that you can use instead. Here are a few examples, and I'll put links for everything in the description as usual. Once I've selected the plants I want to use, I select them all and press the M key over them in the file menu. This will put them into a group and I name this grass. Then go back into the particle settings and in render select collection and then the grass collection. I bump up the scale to about 1 and you can see how I have the basic setup for the simulation, even with the exploding liquid. To finish things off, I head over to the camera and line up the final render using Ctrl, Alt and 0 on the number pad in viewport mode to lock in the camera view. Then adjust its position to what looks best. Lastly, I change the project settings to be portrait and into an Instagram stories resolution. I move over to render mode and mute out the two collision objects in the render and viewport. I add in an HDRI and set the render settings under film to transparent, and also turn off the glossy ray visibility in the HDRI. All that's left to do now is the material of the liquid. I drop on a quick glass shader I had and turned up the roughness and made it a yellow colour. Then headed over to the flowers and made them a little smaller and gave them a bit of a randomness. I also add an aerial light and position it to the left and behind the simulation and turn this up to 5000 watts, and then turn the HDRI strength down to a strength of 0.5. So the last thing I did was head over to the compositing window and add a viewer node, then connect this from the main connections. Then I add a glare node and a lens distortion node and add them in sequence as shown. I turn the glare node to fog and add a size of 6, and then change the dispersion to 0.04 in the lens distortion. Back in the particle settings under rotation, I also click dynamic. Here I'm just making the flowers start to flow 15 frames from the start. Finally, I add a little bit of drag and dampening in the particles physics section under forces. From here you can bake the particles and then render it all out. This technique was used in all the different simulations with just the type of flow, size and number of particles being changed, to get the final results you are seeing here. Thanks for sticking around till the end. I hope you found something useful, and I'll catch you on the next video.